Okay, this is lesson 2.3, length of a line. Our goal is to learn how to determine the length of a line segment. All right? So, the first example here is kind of long. We're gonna kind of figure out the equation for the length of the line going sort of backwards doing this, okay? So the first thing we want to do is we'll let 2 points on the coordinate grid be A and B, okay? And then we'll draw a line segment joining those 2 points. Okay, so really I can pick these points at random. I'm just going to say A down here, X and X1, Y1. And then the other point I'm going to pick, well, let's make it over here. I'll just be consistent with the solutions I have. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we'll go up to here. Okay, we're going to make this B. And this will be X2, Y2. Okay, and it's going to seem more complicated without numbers, believe it or not. Okay, but it's just to establish that formula that we should already know, right? The x squared, x2 minus x1 squared plus y2 minus y1 squared, all square rooted. Okay, we're going to draw a line segment joining those 2 points, A and B. Okay. Next, B, it says draw a right triangle below the line segment AB to show its rise and run. Okay, so we're going to draw this right triangle now. And draw it a little bit lighter. Maybe I won't. Okay, there's my rise and run. How are the rise and run of AB related to the coordinates of its endpoints? So how are the rise, so this is the rise, and this is the run. How are they related to the coordinates of these endpoints? Okay. Well, we know how it's related when we calculate slope. When we do slope, it's rise over run. And we know slope is what? What's the equation for slope? Rise over run. Axis. Remember?
I did it last night. Yeah, we did it last night at homework. I just can't remember.
Yeah, slope. We should know this. We've done this many times. Yeah, Andrew?
Y1 minus Y2 over Y2 minus Y1 over X2 minus X1.
Is that right, Liam? Is it? Sounds right. Yeah, I agree. Right? That's how the rise and the run is related, right? So rise, right? We know this. This is all review. Rise over run, y2 minus y1 over x2 minus x1. Right? That's how they're related. Okay. Next, it says calculate the length of a line segment using the Pythagorean theorem. All right. So if we want this length, okay, I'm going to call this line here AB. Right? Because it runs from A to B. So how can if I call this C, right? Makes sense to call that C. How can I calculate the length of the line segment AB? What is the formula for length of a line? Like of a right triangle. Sorry, my hypotenuse, because this is a right angle triangle. Ethan. What's the formula for hypotenuse? The length. Right, so C squared in this case would be what? AB, yeah. So we're going to start with AB squared. So we're going to go like opposite, not A squared plus B squared equals C squared, but we're going to go C squared equals A squared plus B squared. That makes sense? That's the same thing, right? So in this case, A squared would just be one of the lengths here. So here we can say this length here is x2 minus x1, right? And this length here, this is your rise, is y2 minus y1, right? So we can say that that's A squared plus B squared. Now, I'm going to say this. Everyone listen to this very carefully, okay? Do not mix this up with the midpoint formula. Okay, the midpoint formula, remember, it adds the x1 and x2. Remember that, right? It adds them and divides by 2. This subtracts them, okay? That's part of the reason why we do the reverse order. I don't know if you guys were paying attention when Khan said it doesn't matter which way you go because you're going to square it. So you'll lose the negative sign. But it does matter in the sense that you don't want to mix it up with the midpoint formula. Because the midpoint formula, when we add them, it also doesn't matter the order, but we add them as x1 plus x2 divided by 2. You guys remember that? Don't ever add this in the distance formula. It needs to be subtracted. Midpoint, add. Distance, subtract. Okay? Hopefully that's clear. Okay, any questions about this formula I made here? Everyone understands that. Okay, find the coordinates of the vertex of the right angle triangle and the run-rise triangle. Label this vertex D. Find the coordinates of the vertex of the right angle triangle. Okay, I think I named it C. How are the coordinates of D related to the points A and B? Yeah, sorry, I named it C over here. Let's name it D. It wants to name it D. Okay, so the coordinates of D here would be x2, y1. Right? And we know that from these points. I told you this would get a little bit confusing with the x's and the y's. But we know if this is x2, it's going to have the same x value for D. Right? Because this is x over here. And then for y, y1 is going to have the same y value up and down as the a coordinate. So we know that our D coordinate point is going to be x2, y1. Does that make sense? It has the same coordinate of same x coordinate of B and the same y coordinate of A. The reason this is important is just to develop this formula, which we're just going to do one time. Okay, so hopefully this is not too confusing. We're just getting through it. It says find the lengths of AD and BD, so AD and BD. Okay, then use the Pythagorean theorem to determine the length of AB. So the lengths of AD. What is the length of AD? Who can tell me that? Who can tell me that? Adrian. No. Adrian, you got it?
B equals the square root of x2 minus x1.
Yeah, you're going for AB now. I just want the length of AD. Who can tell me that? Yep.
x2 minus x1.
Good. That's what it is, right? It's just this point minus this point, right? That's how we get the length. So x2 minus x1. Okay? And the length, likewise, of DC, Douglas?
y2 minus y1.
Yeah. Okay, right? We want to know the length of this. DB. Why did I say DC? DB. You're just going to minus these y values. Anyone confused there? Any questions there?
So, sir,
Yeah.
we use the more complicated equation for the hypotenuse and then that one for straight lines.
Yeah, the straight lines is easy, right? You just minus the x values. That's going to give you the, right? So yeah, we do. But again, this is all looking very complicated because, again, we don't have points. That's what's making it look so weird. But we're going to get there. We're almost there. Then use the Pythagorean theorem to determine the length of AB. So AB, we know, squared is going to be equal to AD squared plus DB squared. Does that make sense? This length, hypotenuse, is equal to this square plus this square. Right? Right? So now we can just plug these two in. Now we get our famous equation here when we square root everything. So the AB squared just becomes AB. And unfortunately, can't just knock off those squares. As Khan said, you have to take the square root of each of them squared. Okay, any questions there? The distance points A and B in the coordinate plane is therefore what? It's that famous equation, right? We just have it right here. A, B equals square root x2 minus x1 squared plus y2 minus y1 squared. Okay? That's the theory. We've done the theory. Now we can do the actual problems. Switching that over. Example 1. Find the exact and approximate length of the line segments with these endpoints. So when it says exact, what it's actually asking for is you to leave the square root sign in the answer. Because you know when we square root something, we usually get a bunch of decimals. So when it's saying I want the exact, that means you leave it with the square root. And then when it says it wants the approximate, that means you put the square root on your calculator and you approximate the decimal value. Okay, does that make sense? It's asking for two answers here. All right, so here's my endpoints, T and K. So what is our formula for distance of the line segment, TK? TK is equal to what? Just Ethan, we went through this like 5 times now. Milkias, what's the formula? TK, we know what the distance between these points is going to be what? Okay, well first we got to do what? What's this whole thing? Good, square root. Okay. Now what do we do? Minus 2, yeah, that's x2, yep. Yep. Excellent, yep. All of that. Yeah, squared, okay, then. Yep. Yep. All of that squared. Good job. Excellent job. Okay, we have that. Now we have to do a bit of basic math, right? You guys have to be comfortable doing this pretty quickly here now. A lot of negative signs, we got to deal with them. -2 minus -1 is -2 plus 1, which is -1 squared, plus 4 plus 3 is 7 squared. So we get square root of 1 plus 14 equals square root of 15.
That's the exact number.
Yes. Sorry, 7 squared is not 14, it's 49. My bad. Nobody caught me. Ethan, you didn't catch me there. What's going on? I was testing you. That's an easy one. 7 times 2 is 14. 7 squared is 49. So that's more like it. The square root of 50. So that's the exact answer. Now to get the approximate answer, it says to 2 decimal places. So let's see. If I put this on my calculator, I can find the square root sign. Don't tell me. Don't tell me. I need to learn where this square root sign is. Okay. Okay. So 7.0710678812. So that I need to approximate to 2 decimals. So how do I do that? I look at the second decimal, 1, 2, this number. I need to decide, is that number going to stay the same or is that number going to move up? In this case, in order to decide that, I look at the next number. It's a 1. So what do you think, Rudy? Is it going to be 7.07 or 7.08? What? Why would the... Remember, you got to decide if I'm going to raise the 7. The 1 is deciding. Am I going to push that to an 8? Staying the same. Good. There is my approximate answer. Any questions? This is the approx. Okay. All right, we're gonna try and move quickly here so we can give you some time to work on the homework. Okay, Jan and Tara are planning a canoe trip in Georgian Bay. The dock where they will launch the canoe is at point 22 on their map. That's this point here. So this is where they're leaving from. The campsite where they will stay for the first night is at 65B over here. Okay? And the campsite for the second night is 71 over here. Calculate the distance from A to B to C and back to A. Oh boy. So we got to calculate this and then this and then this. So what it's actually asking for us here is 3 distance calculations. And then it says, provided each square on their map has a length of 4 kilometers. All right. So let me tell you a little hint here. If it gives you a grid that is not 1-to-1, it gives you a grid and is telling you the new distance between the squares, deal with this. Deal with this at the end. Okay? If you try and deal with that at the beginning, you change all these numbers here, multiply every number by 4, is going to be a lot of work. So you want to deal with that at the end. Okay? So we're just going to deal with the numbers that we're given, and we'll deal with that number at the end. Okay. So step 1 here, we want to find the distance of A, B, right? Because this is where they start. They start at A. So step 1, we're going to get A, B. Okay? So our distance formula we know for AB is what, Stefan? I'll help you at the beginning. Square root of what?
Square root. In brackets. 2.
No, we want to do x2 minus x1, right? So what's x2?
Oh. 6
Yep, 6 minus
minus 2
Yep. Squared plus what?
plus 5
Yep.
minus 2
Good.
squared.
Good. Okay, what's 6 minus 2, Stefan?
4.
4 squared plus 5 minus 2.
3.
Okay, so we get 16 plus 9 equals square root of 25. Beautiful. 5. I have a good feeling that we got that one right. Whenever you get that nice, juicy round number, you know you're right. All right? Typically. Okay, that's our AB. That's our step 1. Let's go step 2. We're going to go for, which line segment should we go for, RC? What should we go for? We got AB. What should we go for next? Yeah, BC. That makes sense. Okay, so RC, tell me the equation for BC.
6 minus 7 squared.
Okay, I don't like 6 because that's C, right? And this is B over here. Can you see those two?
Yeah.
Okay, so what is x2?
7.
Yeah, 7. Good.
Okay, 7 minus 6.
Good. Plus.
Plus 1 minus 5 squared.
Good. What's 7 minus 6?
Negative 1.
Sorry?
Negative 1. Oh no, 1.
No, just 1. It wouldn't matter if you said negative 1, but okay, 1. And then 1 minus 5?
Oh,
-4. 1 plus 16 square root of 17. Not as nice as our juicy 5, but I think we're still good. Nice thing about this, if you ever get a negative in the square root, you know you did something wrong, right? Because this has to be a positive number, this has to be a positive number, right? Because it's squared, it's squared. So before you square root, if there's something negative here, you know you've done something wrong. Okay? Next, what would step 3 be, Josiah? Or, yeah, Josiah, sure. Step 3. So we've gone from here to here. Now we've taken our canoe from here to here. Where's next? Yeah, C to A. Or AC, whatever, same thing, right? Let's call it AC, sounds better. Okay, that's our length. Now we're looking for, so Josiah, what's going to be my formula for the length of line AC? Sorry, what do I start with? AC equals? Square root, yeah. Bracket? Okay. 7, yeah, minus. Good. Yep. Yep. Bracket, don't forget the bracket, yeah. 2 minus 1? Or 1? Yeah, 1 minus 2 here, right? Again, it doesn't matter which way we went. 2 minus 1 probably would have been better. But that's okay. We're going to square them, so we'll get a whole number. So we get 5 squared plus -1 squared equals 25 plus 1 equals square root of 26. All right. So our final step would be what?
the 4 kilometers.
Yeah, we got to deal with that 4 kilometers. So first we're going to add up all distances. And then we'll deal with 4 kilometer thingamajig, right? So we're going to add them all up first. So here's our total distance is equal to what, Douglas?
Sorry, can't say that.
Oh, sorry. What's our total distance equal to? Douglas. Just tell me and then tell me the answer.
5
5
plus
plus,
17
yep, root 17 plus,
plus root 26.
good. That's what?
48.
48? Sure about that?
14.12.
That doesn't look right. 48. Try it again. So 5 plus root. If you're not getting the right answer, you might have your calculator.
I got 9.7.
Time root. Everyone do this on their calculator. You got it wrong also, Andrew. It should be 14.222.
4.22.
Am I young?
Okay. And now, finally, at the very end, we are going to deal with the 4 kilometers. So what do you think we do if each one of these squares is 4 kilometers? What is squares normally when we deal with problems? What are squares on a grid? What do they go by, typically? 1. Yeah, 1 unit, right? So what do you think we're going to do with this, Jafet?
Multiply it by 4.
Right. That's it. That's how we deal with that last part. 56.8885. So to reduce this to 2 decimal places, I'm going to look at the second decimal place, this guy, and I'm going to decide whether he's going to stay at 8 or he's going to move up. Okay, and Jaden's going to tell me. What do you think, Jaden? Yeah, so what will it be? Good, you got it. That's how you round. And then you do this little squiggly, which is fun to do. That means approximately. Or actually, I think you can use a dot as well. I don't know what's the difference between. Here's someone Google that. The solutions here have a dot. I tend to use a squiggly. It's more fun to draw. But. Any questions with that one? All right, we still got work to do. Let's go. Example 3. We got 2 birds now. I don't know if you can see them here, but there's a little bird here and a little bird there. And they're flying towards a birdhouse that's halfway between them. Okay? So probably a good idea to draw a line. I'm assuming we're going to have to deal with that distance formula again, since that's what this whole lesson's about. So in order to do that, let's draw a line. There's our line between our 2 birds. Now it says the birdhouse is halfway between them. So I'm going to draw a little birdhouse somewhere around there. So we're trying to find out where that birdhouse is. Okay, what are the coordinates of the birdhouse? So anybody can tell me how we might do that? Yeah. The midpoint, yes, yesterday's lesson. Okay, so the midpoint of AB is equal to what? Yeah, it's the birdhouse, but how do I find it now? I have A, right, and I have B here. So how do I find the midpoint? Yeah, Douglas?
x1 plus x2 divided by 2.
Excellent, and then y1 plus y2. Now I like putting y1 and x1 first here, just to disassociate the other formula, right? To give our brain sort of a wake up that hey, we're adding these, we're not subtracting. So I'm going to put the x1 and x2 first. Okay. So keep going, Douglas. What would this be?
I get negative 4
Yep.
plus 10.
Yep. Yep. Keep going.
4
Yep.
minus 2.
No. Not minus.
Oh wait, plus minus 2.
Yeah, see, that's gonna happen now. Unfortunately, you won't be the first, you won't be the last to do that mistake. You have to add when you're doing midpoint. Midpoint add, distance subtract, okay? Midpoint add. Okay, so I'll finish this off here. Minus 4 plus 10 is 6, divided by 2 is 3. And then 4 minus 2 is 2, divided by 2 is 1. Any questions there? All right, how far will each bird fly to the nearest tenth of a foot to arrive at the birdhouse if each grid on the graph represents 300 meters? So let's deal with that at the end, okay? Let's figure out how far they need to fly to arrive at the birdhouse. So what can we do here? We have this midpoint, right? This birdhouse point here is 3, 1. I'll call it H for house. Okay, so we have that midpoint. Now we want to know how far they'll fly. So what we actually want to know is BH and AH. Does that make sense? Right? So how can we figure that out? BH and AH. Yeah.
You calculate the distance between HA or HB because they're opposite distance. You can just do 1.
Yeah, good, perfect. We know that they're the same distance because it's the midpoint, so we can just find the distance of one of them. So let's choose AH. That's our distance AH. What's the formula going to be, Andrew?
It's gonna be AH equals H equals 3.
What do you start off the formula with?
So square root.
Okay, good. Square root, yeah, now?
So minus 4 minus 3 bracket the exponent of 2
Okay,
plus 4 minus 1 to the bracket 2.
minus 4, minus 3, and then 4 minus 1. Yeah, looks good. Okay, so then we will do some math here. We get negative 4 minus 3. That's minus 7 squared is 49. Plus 4 minus 1 is 3 squared is 9. So we're going to get the square root of 58. That's how far they got to fly. And it says, to the nearest tenth of a foot. Are you kidding me? They're switching units here from feet and meters? I don't think that's intended. Yeah. I'm going to say to the nearest tenth of a meter. I think that's just cruel, trying to make you convert units between foot and meters. It's about 3 foot per meter, by the way, but I don't think that was the intention of this question. So let's just say to the nearest tenth of a meter. So what am I going to do with this number, Chenier, and this number, Chenier? What do you think?
What you gonna do with it?
Yeah, what am I going to do with it? So we calculated that the distance with root 58, if all of these were ones, okay, but they're not. They're actually 300 meters in this case. So what should I do with these two numbers?
A tenth of a foot is not a foot, right?
We're not in feet anymore. I got rid of the foot problem. We're in meters now.
Alright.
So what should we do with these two numbers? Just like we did over here.
Just times it.
Yeah, just times it. Exactly. Just times it. So we would just do root 58 times 300. This will give us our answer in meters.
I should do that on my calculator second.
Sorry?
Do it on my calculator.
Yeah, do it on your calculator. I can't do that in my head, unfortunately. What'd you get? 130?
2,000.
Yeah, I got 2,284.73. So nearest tenth of a meter, tenth is the first decimal. So I got to decide if that 7 is going to move up or stay the same. And what does it do, Chenier? The 7, is it going to move up or stay the same?